Hi, everybody. This is something you missed out on when I had lectures at school because I never had my cat hat to teach you ion charges, but today I have my cat hat. We're reviewing units pi and units 4. Unit pi was periodicity. It was the pain in the neck one with the big worksheet, and you had to know where the big elements were, where the small elements were. Very little of that is super important, so I'm really going to limit the questions from there on the final to a couple little bits of trivia and the stuff you're going to use down the road. So today we're reviewing those periodic properties and charges on the periodic table, and that's why I have an excuse to wear my cat hat. So the first periodic property we're looking at is atomic radius. That's basically your size of your atom. Where are the atoms big and where are the atoms small? Larger atoms, the postage stamp of chubby atoms, are down here at the lower left. Cesium, barium, francium, and radium. I think of my old dog every time I think of those because I used to call them the chubby bunny elements, and I used to call her a chubby bunny. So down here at the lower left, one way to remember it is because they're heavier, they sunk to the bottom. I remember the bottom that way. Cesium, barium, francium, and radium are the big guys down in this corner. The nice thing about periodic properties is because the big elements are here, the opposite side will have your smaller elements with fluorine and neon and oxygen. We went through a big deal of why those were big and those were small when we talked about it in class, but right now that's what I'm saying. This is your trivia question. Big elements, small elements. Remember, you're marking your periodic table. So, there you go. Electronegativity. How greedy something is in a compound for electrons. We talked about that, how you share your cookies. Do you share nicely? Do we split them 6 and 6? I'll never say no. I usually share. I shouldn't say I'll never. I usually share, but I share how I want. So I get my cookies first. Then you might get some crumbs. And some people will just take the 12 cookies and run. So, what you need to know about electronegativity is it's how bad atoms want electrons, but your most electronegative element is fluorine. Fluorine is the greediest of the greedy and the brattiest of the bratty. That idea comes back when we talk about Lewis structures. What makes compounds with what? So fluorine is your most electronegative element. Those are the two ideas we only got in that packet that I need you to know. Valence electrons come up as important because they figure out our charges for our ionic compounds. Valence electrons are pretty easy. We're only going to look at valence electrons for our S block and our P block. It's the group number if it's below 10, and if it's above 10, you just ignore the 1. Group 1 valence electron. Group 2 valence electrons. When I go to the other side of the table, to the P block, this is where I start ignoring the 1. So group 13 has 3, 14 has 4, 15, 5, etc., etc. In the packet I sent you, I showed you how this works out with an electron configuration. Quick example. If I'm looking at, say, boron. If boron is that 3-legged dinosaur that sits on my desk. Boron is number 5. We just reviewed electron configuration, so if I keep going with that idea, my first one is 1s2, and that used 2 electrons. I have 3 left. 2s2 lets me have 1 left, and that electron goes in the 2p orbital. Valence electrons are the one with the biggest number out in front. So those are my valence electrons, and 2 plus 1 is 3. That's where I'm counting valence electrons. Do you need to know that? No. Do I feel obligated to show you that because you know electron configurations? Yes. How do I get the number of valence electrons in boron? Boron's in group 13, so it's 3. I don't write electron configurations to do it, but you're basically doing that and just skipping a step. If I say chlorine, and you go chlorine's in 17, that's 7th valence electrons, it's coming from its electron configuration. So we're good there. That's where I got your number of valence electrons in that chart, but next, how we get to 8 valence electrons. And I'm going to write these charges above on this periodic table, so you might want to be marking yours the same way too. You can always print it out or go back to it later, come back to the video and do this too. So, need my marker and my kitty paws at the same time. With my number of valence electrons, there we go, we'll compromise. With my number of valence electrons, if I have less than 4, I'm going to throw them out. I want 8. So if it's less than 4, it's easier to work backward and kick them out. If it's more than 4, I'm going to gain them because it's easier. 4 is the turnaround point. Carbon's group we'll talk about in a bit. So group 1 valence electron, it's easier just to throw it out. Electrons are negative, so when I throw it out, my new charge is +1. I have 2 valence electrons in group 2. Let's throw them both out. +2. I'm coming back to these charges for ionic compounds. For group 13, I have 3. Still not half, so I'm going to throw all 3 out. Now, 14, 14's just going to share. Carbon share is real nice. If you want to talk about carbon, take organic chem. I don't want to talk about carbon. So group 15, I'm over half. Now it's easier to gain the electrons, and they bring their negative charges. So group 15 is -3. Group 16 is -2. And group 17 is -1. Those are your charges. Now, something quickly from periodic properties that we talked about, reviewing what's an anion and what's a cation. So over here, what I just did with nitrogen, oxygen, and fluorine, those are anions because those are negative. Mrs. Sear used to tell her class that anions were like onions, that onions are bad. I love onions. But if you want to think of it, if you don't like onions, anion and onion are kind of alike, so they're negative. I just think of Shrek and ogres have layers like onions have layers. Here's how I remember it. And look, I've got them today on the left side of my table. And just so you know, this whole middle, and if I had the bottom drawn too, that would be these also. Those are positive, and cat ions are positive. And I have never gotten to say that while wearing pause before. So today is a good day. High 3. With these ion charges, they're going to affect how these substances form, how we make ionic compounds. And that's what we're going into with nomenclature. This was the stuff we did right at the beginning that you guys all told me was easy. So, let's go over this. We're only going to do ionic compounds today. We'll go back and catch polyatomic and the other types tomorrow. So what we're doing here, we've got a positive and a negative ion, also known as a cation and an anion. We always write the cation first. Remember the rule at my house on the stairs? Dog goes first. You got to let her down the stairs first. Rule here, cat goes first. So, very simply, I'm going to give you a pair of ions, a pair of elements that form ions, and we're going to work on these. I'm going to try to tip the computer down a bit and be able to do them below this, take out that configuration, and let's look at a few. If you want to do the names and formulas of calcium and chlorine, those 4 practices on the next page, go for it. I'm going to work on them now. If you like me to do them better along with you, that's up to you whether you pause or not.